Okay, we're on to our last video of this unit, and we're on to our last two quadrilaterals. Today we're going to talk about kites and trapezoids. Kite is just what you think it is. It looks like a kite that you fly in the sky. It's this shape right over here to the right. A kite is a quadrilateral with two pairs of consecutive congruent sides. So remember, with a parallelogram, it was the opposite sides that were congruent. With a kite, it's the consecutive sides, so it's the two sides that connect that are next to each other. So if a quadrilateral is a kite, then its diagonals are perpendicular. So that means that these two diagonals right here are perpendicular. So AC is perpendicular to BD. Now in our rhombus, the diagonals were also perpendicular. So you want to make sure you don't mix those two up. Just remember that in the rhombus, all four sides are the same, and in the kite, it has two sets of consecutive sides that are the same. And our next property is if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So remember, in a parallelogram, both sets of opposite angles were congruent, but in a kite, it's only one set. So angle B is congruent to angle D. So we're not going to list out all the properties. It's just two more properties there to deal with, so we're going to go ahead and get right into working a problem with a kite. So in kite ABCD, angle DAB equals 54 degrees. So that's angle DAB, which is this entire angle. So this entire angle here is 54 degrees. And the measure of angle CDF, so CDF, that's this angle, is 52 degrees. And the problem says find the measure of angle BCD. So it wants us to find this entire angle. Well, it might look tricky at first, but it's really not going to be that difficult, because if we look at our kite, we know that it's a kite, so we know that our diagonals are perpendicular. So that means that this angle here is 90 degrees. Well, all of these angles are 90 degrees. So we know that this triangle has to add up to 180 degrees, right? Well, we know that this one's 90 degrees. So if we just do 90 plus 52, that gives us 142 degrees. Then we're going to do 180 minus 142 degrees. And we're going to get that that is 38. So this angle right in here is 38 degrees. Now if we could find out what this angle is, we just add them together. So something else we know is that these consecutive sides here are congruent to each other. That means that this triangle that you see here, triangle BAD, is an isosceles triangle. So that means these two angles are congruent. Well, we could find those two angles real easily by doing 180 minus 54 gives us 126, and then if we divide that by 2, divided by 2 is 63. So the angle we just found, right here and right here, these are 63 degrees. So 63, 63. Now, if we know that this angle and this angle are congruent, and the reason we know that is because if you look up at the picture, our opposite angles that are always congruent are the two that are between the two sides that are different, if that makes sense to you. So it's not going to be this angle and this angle. It's going to be the two that are between the sides that are different lengths. So if this is 63 and this is 52 and this is 63, then this is 52, which makes this 38. So 38 plus 38 is 76 degrees. So that's what our angle BCD equals. And there's other ways you could fumble around this triangle and figure that out. I was trying to do it for you just Real quick and easy, no formulas, no overthinking it. All right, so next one says find the measure of angle ABC. Well, ABC, well, we've already got that right there. 65 plus 52 is 117 degrees. Okay, so not too bad. All right, we're going to move on to a different quadrilateral. This one is called a trapezoid, which you've seen before. And a trapezoid is a quadrilateral with only one pair of parallel sides. So you see the top and the bottom, which we call the base. Okay, and we're going to refer to that later as B1 and B2. And it doesn't matter which one is which. Okay, so the bases are the top and the bottom, or the parallel is what you really should remember. Because if I draw a trapezoid like this, and I tell you it's a trapezoid, these two are parallel, then this is the base, and this is the base. So don't get in the habit of thinking top and bottom for base. Base is the ones that are parallel. The non-parallel sides are called legs. And the two angles whose common side is the base. So if we look at this picture, we see two angles whose common side is a base. So this is a base, and there's an angle here, and an angle here. So this angle and this angle are the base angles. But up here we also have two base angles because they share this base as a common side. And an isosceles trapezoid is trapezoid whose legs are congruent. So this one that I drew here, clearly the two legs aren't congruent, but if you look down in these pictures, they are congruent. So if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So angle A congruent to angle D, and angle B is congruent to angle C. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So when we see that angle A is congruent to angle D, we know that trapezoid ABCD is isosceles, and all the rules of an isosceles trapezoid will apply. A trapezoid is isosceles if and only if its diagonals are congruent. So AC is congruent to BD. And the other shape where the diagonals are congruent is a rectangle. So you want to make sure that we don't confuse those. Find the measure of angle A. Well, I see that these two sides are the same. So that means this is an isosceles trapezoid where this angle is congruent to this angle, and this angle is congruent to this angle. So that means this is 100. Well, if you haven't caught on by now, all quadrilaterals add up to 360 degrees. So 360 minus our 200 leaves us with 160. 160 divided by the two angles that are the same is 80. So the measure of angle A is 80 degrees. All right, quick example. Here's our trapezoid. It says AD equals 12x minus 11. So A to D, that is, I'm going to color it blue instead of writing on it. So that's the blue one. And BC will be the red one, is 9x minus 2. Find the value of x so that ABCD is isosceles. Well, if it is isosceles, that means that AD is congruent to BC because the diagonals have to be congruent. So we do 12x minus 11 equals 9x minus 2. And just like I told you the first day of school, every problem we do in here, we're either going to set two things equally to each other or we're going to add them up to 180. So you get 3x equals 9, divide both sides by 3, x equals 3. Okay, nothing to it. All right, here's a trapezoid, and we see it has this segment drawn right through the middle of it that goes from the midpoint of one leg to the midpoint of the other leg. That's called a midsegment. Okay, our trapezoid midsegment theorem tells us something that's kind of common sense. It says the midsegment of a trapezoid is parallel to each base. So all these are parallel. And its length is 1/2 the sum of the lengths of the bases. So xy, our midsegment, equals 1/2 b1 plus b2. Okay, so if we come down and take a look at this quick example, it says find EF. All right, so EF is right here. Well, we know that it's 1/2 the sum of the two bases. So that's 1/2 of 21.5, which is 10.75. Okay, so all we do is it's 1/2 of this plus this. It's like it's the average of those two. Okay, so find EH. Well, I know that XY equals 1/2 FG plus EH, right? Because I know that the midsegment equals 1/2 of the base 1 plus the base 2. I'm going to do this for you, okay? You go ahead and write it. We're going to multiply both sides by 2. And that gives us 2xy equals FG plus EH. And I want to know EH, so I'm going to subtract FG from both sides. So I get 2xy minus FG equals EH. And so that's how I can figure out what EH is. I can do, you may be out of room here, but I can do 2 times 16.5 minus 25. And that'll equal EH. So 16.5 times 2 is 33, minus 25 is 8. Okay? So that's the fancy, look at me, I'm good at math, algebra way to do this. Another quick, easy way to do it is to know that to go from 25 to 16.5, we need to travel 8.5 units, okay, by doing 25 minus 16.5. That equals 8.5. So to get from 16.5 to here, we need to travel 8.5 also. Okay? So we're going to take 16.5 and we're going to subtract another 8.5. And that's going to leave us at 8. So either way, you're going to figure out that the midsegment was 8. And that's the end of the video. So we'll be reviewing, and hopefully everybody's going to do well on this test. Good luck.